It's homework time, yes! Here we go again. Lesson 39 homework. Let's start out by writing our name at the top of the page, yes. All right, I'll write my name, you write yours. And then we'll write today's date. I'll write today, you write the actual date, where and when you are in this wonderful world of ours. We are to use the Distributive process to solve. Read, draw, write. Yes, we know by now. Ground turkey, lower in fat, is sold in packages of 2 1/2 pounds. Dawn, bless her heart, bought 8 times as much turkey that is sold in one package. They're being mysterious with us here. So one package we see is 2 1/2 pounds. She bought 8 times that amount. Okay. For her son's birthday party. Man, her son got some turkey-loving friends. How many pounds of ground turkey did Dawn buy? I say it again, bless her heart. All right, so 8 times as much turkey. Well, look, we can make this pretty simple. If we're going to go ahead and draw ourselves a little tape diagram, we'll just make ourselves a pretty little rectangle. And we need to draw 7 lines to make 8 parts here. So 1, 2, 3, 4, 5, 6, and 7. Oh, those are reasonably. Yeah, and each of these is 2 1/2 pounds, okay? So I'm just going to do it this way. I don't feel like labeling each of those 8 parts 2 1/2 pounds. So the whole thing, though, however, is what? Well, it's 8 times those 2 1/2 pounds, isn't it? And the abbreviation for pounds is LBS, and stop me if I've explained this before, but it comes from the Latin word libra, meaning weight. That's why LB is the abbreviation for pound. And actually, you could use LB for either pound or pounds, but it's become common usage to use LBS for pounds. Interesting. Yes. All right, I'll stop now. All right, so 8 times 2 1/2 will tell us what Dawn needs here, and we're going to use our good old friend, the distributive property, to say, okay, well, we'll do 8 times the whole number in that mixed number, and then add that to 8 times the fraction in that mixed number, which will give us what? 8 times 2 is 16, and 8 times 1/2 is 8 halves, and we see very quickly here, don't we? Yes, the 8 divided by 2 is 4. 16 and 4, well, we could do that step in our heads, can we? 16 and 4 make 20. So Dawn, bless her heart, Dawn bought a whopping 20 pounds of ground turkey. Turkeys, run for safety! Oh my goodness, that's a lot of ground turkey. I think if you're making even big fat quarter pounder hamburgers, that's 80 hamburgers? 80 turkey burgers? How many kids are coming to this party? Go to Chuck E. Cheese, woman. All right, let's go on. And here in our long parade of Eureka Math word problem characters, we add Trevor and Rick, who have stacks of books. Trevor's stack of books is 7 7/8 inches tall. Rick's stack, correct, is 3 times as tall. What is the difference in the heights of the stacks of their books? Well, since we're talking about something that's vertical, I'd like to, just for the heck of it, draw my tapes vertically, and note that we do need 2 tapes here because we're asking what's the difference, how much more, how much less, so we're comparing, so we do need to draw 2 separate tapes. All right, so here's Trevor. He's got his measly, we're gonna keep it pretty small. I'll make it a little wider though so I can write inside it. His measly little 7 7/8, and put the little 2 marks there that mean inches. So that's Trev. And along comes Ricky. And his is, yes, 3 times as tall. Go, Ricky. Go, Ricky. You got your books now. Go, Ricky. All right, see, so, and I can even do it like this. Say, okay, there's one Trevor. There's another Trevor. Okay. So altogether, this is 3. I can actually call it 3 times Trevor. here. I can say 3 times t or even just 3t when you get to algebra. All right, so we can compare them here, but what are we trying to find? Well, this is what we're trying to find. And I'm going to call it B, this space here. And I know they usually use brackets, but I'm using this. So this is what I'm trying to find. I'll put B, question mark. That's what we're trying to find. So B, and I'm going to do it this fancy way here, that's going to be if I take Ricky. Okay, B, the difference between them will be 3 times Trevor, which we know to be 7 7/8. And then if I were to subtract Trevor, that would give me B. But you notice what you're doing when you do that? Instead of having 3 sets of 7 7/8, or 3 Trevors, really it just comes down to having 2 Trevors. So B also, and that's why I wrote that out so you could see what I was doing here. I have 3 of these minus 1 of them is the same as saying, I can also say now that the difference between them is 2 times 7 7/8 and save myself the whole step of multiplying and then subtracting, which is more prone to error. It's not has nothing to do with laziness. It's doing things less likely to make mistakes, being efficient. So we can use a good old friend, a distributive property here, multiply the whole numbers, add to that the product of the 2 times 7/8, and 2 times 7 of course is 14, and this would be how many eighths? Yes, again we have 14 eighths. Okay, lovely. And so think about 14 eighths. So we'll leave the 14 alone for a moment. How many eighths in 14? Well, there's 1, because 1 times 8 is 8. 14 minus 8 leaves 6 eighths. Okay, so our final answer there would be 14 and 1 make 15, and 6 eighths is the difference between their stacks. So Rick's stack, you check out Rick's stack, is 15 6/8 inches taller. Booyah! Let's go on to number 3. Brat. Ginger again. Good for digestion. You know, it's nice morning tea. And however, it takes 8 3/4 yards of fabric to make 1 quilt. Okay. Gail needs 3 times as much fabric to make 3 quilts. Okay, well, I mean, that makes sense, right? 8 3/4 makes 1 quilt. She's going to need 3 times as much to make 3. She already has 2 yards of fabric. So how many more yards of fabric does she need to buy in order to make 3 quilts? And so this one is a little different from the last one. Okay, we are going to have to multiply and subtract in this case, and our tape diagram will make it clear why. So if you look at what Gail needs here, we'll call this G. She needs, I'll make a nice healthy sized tape diagram, right? Okay, so she's going to make 3 quilts. Okay, so this is 8 3/4. I know that slanted line I sometimes do on my 4s. I'm trying to get better at that. This is 8 3/4. And this is 8 3/4. Now here's the thing. She already has 2 yards of fabric. Okay, so look, she doesn't need, out of here, she doesn't need to buy those 2 yards there. Okay, so I can say, like right here, this is 2, and she doesn't need to buy that. All right, I'm going to signify it in this way with these X's here. What I'm trying to find then is this, and we'll call it Y for yards. All right, so she only has 2 yards, but she needs this much. Okay, so there's 2 ways we can do this. We could easily subtract this in our heads, right? So we can multiply 8 3/4 times 2 and then add 6 3/4 to it. Or we could do 3 times 8 3/4 and then subtract the 2. I think actually that's going to be a better way to go. So what I'm proposing then is that Y is 3 times the 8 3/4, and then we'll subtract out what she already has, the 2 yards, in order to see how much she needs to buy. Okay, so let's look at this. We'll distribute out. We'll do the multiplication here. We know it's going to be 3 times 8 plus 3 times 3/4, and then we'll subtract the 2. You mathematicians, I know technically I should be using brackets, but that has not been introduced yet, so we're just going to play pretend here. Okay, so 3 times 8 is 24, and then 3 times 3/4 is, yeah, you're getting good at this, 9/4. And then once we get this here, then we can subtract the 2 from it. So what is 9/4? So this will be 24. Well, how many 4s in 9? There are 2, because 2 times 4 is 8, and from 9 leaves, yes, 1/4. And once we put those together, we can subtract the 2. So what are they together? Well, 24 and 2 make 26 and 1/4. There it goes again. Minus 2. All right, we got that, right? 24 1/4. See, that's why I thought, because there's a nice even 2, nice round number, it's easier to subtract it at the end. So Gail, bless her ever-loving heart, needs to buy 24 1/4. And what are we talking about here, Ed? Yards of fabric, and you could add to make 3 quilts. I'm happy the way it is. Let's go on to number 4. You know, Eureka Town is such a happy place. There are always class parties and people buying things for them and people doing arts and crafts and dogs eating dog food. And here we have Carol making punch. And she used 12 3/8 cups of juice, all right, and then added 3 times as much ginger ale. Then she added 1 cup of lemonade. How many cups of punch did her recipe make? And so when you start drawing the tape, and we're going to have all one tape here because we are just adding these, I mean, in physically thinking about making punch, you know, we're just adding these things to one big bowl or bucket, all right? And so we're adding them all together. We're not comparing, saying how much more, how much less. So we'll have one nice long tape here. All right, so here we go. I'm going to draw a nice long tape here. So when we think about it, we start off with this 12 3/8 cups of juice, right? And kind of space things out best I can here. Then 3 times as much ginger ale, okay? So 3 times as much as, well, 12 3/8. So what I can do is I can say, hey, this is 3 times 12 3/8. I could also have made 3 parts to this and written 12 3/8 in each one. All right, and then 1 cup of lemonade. Okay, so when I look at these parts here, just to look at these for a moment, how many 12 3/8 do I have here? Oh, there are 4 of them, are there not? Yes. So 4 times 12 3/8. So instead of doing 3 times 12 3/8 and adding another 12 3/8, I can do it just in one fell swoop. All my chickies in one fell swoop. All right. And then I just need to add in the 1, and that will give me P for punch. And so my recipe for punch, how much punch do I have here, is going to be, and similar to the last one, where we're going to do the multiplication, the whole number and a mixed number, and then, in this case, add, or last time we subtracted something. So 12 3/8, and then we have to add in that 1 cup of lemonade. All right, so let's use our good friend the distributive property to make sense of this multiplication. We will do first the whole number, 4 times 12, get that product, and then add it to the product of 4 times 3/8. And don't forget, then we're going to add 1 to the whole thing. Well, let's do these steps here, okay? So 4 times 12 is 48, and 4 times 3/8, that's right, 12/8. And then don't forget, we will still be adding 1 to it after we do this. Now, guess what? We can do these 2 steps in our brilliant little heads here. Okay, so we have 48, right? Then we have 12/8. What's that equal to? Well, there's 1 8 and 12. And then 12 minus 8 is 4. So 1 4/8. Can we add that to 48 in our heads? 48 plus 1 4/8 is 49 4/8. Add another 1 to it. 49 4/8 plus 1, 50 4/8. And if you want to write out the individual steps there, go for it, brother. And you might have noticed right off, yes, that's an equivalent of 1/2. So we would be totally right to say 50 1/2, but our instructions don't say to do so. So I'm going to leave it as 4/8. So her recipe, Carol, made 50 4/8 cups of punch. All right, we're all done with Carol punching us. Let's go on to number 5. And adding to our Eureka Land cast of characters, we have Brandon the driver. I don't know why he's driving around so much. Maybe he's just lost. Brandon drove 72 7/10 miles on Monday. He drove 3 times as far on Tuesday. How far did he drive in those 2 days? And this is similar to ones we saw before, where we can do this in 2 steps, but we can make life a little bit easier and do it in 1. So when we draw our nice little tape diagram here, we have, okay, let's look at Monday. And I'm doing 1 tape, by the way, because there's no comparing going on here. There's Monday and then Tuesday, and we're asking for a total. So we're putting it all together. If you drew 2 tapes, it wouldn't necessarily be wrong. It just isn't the best way, okay? And then 3 times as far on Tuesday. So this is 3 times the 72 7/10. This is actually easier than some of the other ones we've done. And so when we look at the whole thing, because that's what we're being asked in the 2 days, this is Monday and this is Tuesday. You must have gotten really lost on Tuesday, man. So how many 72 7/10 do we have here? Yes, there are 4 of them in all. So if we're going to call this D, say, D would be 4 times 72 7/10. So if you did 3 times and then added it again, you'd get the right answer, hopefully. But, this is 1 less step, less likely to make mistakes. So let's use our good old friend distributive property. We'll be doing 4 times 72 and then adding that to 4 times 7/10. Lovely. 4 times 72 is not quite as difficult as it might seem. Watch, we can even do it in our head. Do it backwards. Do 4 times 70. 4 times 7 times 10, you can think of it as 28 times 10, 280. Hold on to that, 280. 4 times 2 is 8, 280, and 8, 288. Okay, beautiful. So equals 288. And then 4 times 7/10, well, we just did 4 times 7, it's 28. Now we're talking about tenths. And tenths are a little easier to simplify, I think, than other ones. So it'll be the 288. How many 10s in 28? Yeah, you can see there's 2, and that leaves 8 tenths. Beautiful. Can we put these together? Oh, yes, we can. 288 and 2 make 290. And don't forget about the 8 tenths. So how far did Brandon drive? So Brandon, dazed and confused as he was, drove 298 tenths miles. Don't forget to put the unit of measurement, miles, in 2 days. Go Brandon. And we are now on to our last one, number 6. Wrapping it up. Gas. The Risers got gas. Mrs. Riser and her gassy self used 9 8/10 gallons of gas this week. Mr. Riser used 5 times as much. He's been following Brandon around, driving around aimlessly. He used 5 times as much gas as Mrs. Riser used this week. If Mr. Riser pays $3 for each gallon of gas, how much did he pay for gas this week? Note that we are not looking for the combined. We're just looking for Mr. Riser. So he's 5 times as much as Mrs. Riser. Okay, so let's start off. Let's grab ourselves a little rectangle here and make our tape. And we're going to keep life simple here, as I've been trying to do. This is Mr. Riser, right? So this is Mr. And he's simply 5 times what she used, okay, which we can just write out. 5 times 9 8/10. However, yes, we're trying to find the amount of gas. And so what we want to do then is multiply this times $3 a gallon to find the cost of the gas, not just the amount of the gas. So it's going to be 3 times that. Okay, and actually I can write it out here. It's going to be 3 times 5, 9 8/10, and that'll give us the amount he'll have to pay for the gas. All right, so let's write this out then. So let's go with our gas cost. Well, let's use the distributive property there on the multiplication. It'll be 5 times 9 and 5 times 8/10. And I'm going to just leave out the times 3 for now so we don't kind of muddy the waters, and we'll do that when we get there, okay? Another way to do this, of course, you might have noticed, because multiplication is commutative, we actually could do 3 times 5 and do 15 times 9 8/10. That would totally get you a correct answer. But I'm going to do it in the 2 steps just so we don't get like in over our heads here. So this would be what? 45 and, you got it, 40/10. And I think you see pretty quickly there that 45, great, and then 40/10 is, yes, 4. And so it is 49, but now we need to multiply that by 3. So G is going to be 3 times, oh here, I'll write this down so we don't confuse ourselves. It's 49 is what we got there for the gallons. So it's going to be 3 times 49. There's a way to do this, watch. If we did 3 times 50, that's easy, right? 150. And then we increase that amount by 3. So just subtract 3 and you get 147. Look at that, done. So G is $147. That's how much ye old gas costs. So Mr. Riser, driving around all week like a crazy person, paid, golly, that's a lot to pay at the pump, I tell you. $147 for gas, and you could add this week if you want, but I don't think it's necessary for gas. And look what you've gone and done. Here we are at the tail end of Module 5, Fractions, and you have finished yet another homework time. Congratulations, nice work, and I'll see you again next time. It is once again homework time.